3.3, we are going to start off by making a connection to parabolas again in something you did in grade 11. In grade 11, do you remember with a parabola that if you had a number in front of the x squared, well, if that number was positive, it opened up. If it was negative, it opened down. That's the reflection stuff that we did in 3.2. But you might also remember that if you had a bigger number in there, like a 2 or a 3, your teacher might have said it made the graph narrower. And if the number was less than 1, like the 0.5, it made your graph wider. So in grade 11, pre-calculus, with parabolas, we often talk about narrower and wider. In grade 12, we're going to change those words, and we're going to talk about stretching or compressing something. And we're going to look at both stretches and compressions, both horizontally and vertically. These ones, the first thing we're going to do is color code these. So whatever colors you decide to use. We're going to color code these, and we're actually going to start with the green one, because I want to make some connections between what you did in grade 11 for pre-calculus and what we're going to do now in grade 12. So in grade 11, with a regular parabola, you might remember that we said you go over 1, up 1, over 1, up 3, over 1, up 5. You might remember that as a way to find your next points quickly. Okay? You could also find those points by just plugging things in, right? Instead of going over 1, up 1, over 1, up 3, I could just plug in 2 and I get 2, 4. That would find the point as well. Then on the green one, you might remember that your teacher would have said, if there's a 2 out in front, instead of doing 1, 3, 5, you go over 1, up 2, over 1, up 6, and then it would be over 1, up 10, and that would make your green graph narrower. Unfortunately, narrower and wider, although they're good descriptors for parabolas, they don't necessarily have the same kind of description when you start looking at an x cubed graph or a reciprocal graph. So we need to start to figure out, well, what's the pattern that happens with all graphs that we can describe this very well. So just erase these parts right here. And the part that we look at in grade 12 is we say, well, we notice that if I take this point on my red graph, 1, 1, I now have this point, 1, 2, on my green graph. And if I took the point 2, 4 on my red graph, I now have the point 2, 8 on my green graph. And we notice what has changed, not the x-coordinate, the y-coordinate. And that fits because does it make sense in this 2? Is this 2 getting squared? No. So we would say that that 2 is outside the function, and everything outside the function so far has always affected the y values. And notice with that outside the function being 2, do you notice that your y values have been multiplied by 2? So the wording we're going to start to use for this is instead of narrower and wider, we are going to say that this green graph, we got the green graph by taking the red graph and stretching it vertically. It's like the red graph was glued to the x-axis, made out of rubber, you grabbed onto it and stretched it up. And if I grabbed onto both sides of that red graph and stretched it up, it would make the green graph. Similarly, for the blue graph, I'm going to erase these points. The blue graph, if I have a half in front, That means I multiply my y coordinates by half. So instead of 1 comma 1, I'd have 1 comma half. Instead of 2 comma 4, when I multiply that in half, I'd have 2 comma 2. And the blue graph, we're going to call this one a vertical compression, because we took that red graph that was glued to the x-axis and we compressed it towards the x-axis, which in effect made it wider. And with the purple and the orange graphs, they're exactly the same, except they also include a reflection. So the purple one would be the same vertical compression as the blue one, but it would be going down. And the orange one would be the same vertical stretch as the green one, just going down. Sometimes you're going to get graphs that are partially above the x-axis and partially below. When we stretch things, it's like the x-axis is glued and everything gets pulled away from it. Something that didn't happen in parabolas is we never talked about stretching or compressing horizontally. But that will come up as well in grade 12. So we're going to stretch and compress graphs vertically, as well as stretching and compressing graphs horizontally. When it's vertical, the number will be out front, outside of the function. And that's what we've seen in these examples here. So that's where we're going to start off for tomorrow.